Hello everyone. In this video, we're going to be solving an exponential equation. This could be considered an easier problem than others. I'll be presenting two methods. And let's start with the first one. So, when you have variables in the exponents, what is one of the methods we just talked about? And I think it was an hour ago, right? Maybe less than an hour ago, because that was the first video of the day. And remember, Saturdays and Sundays, you get to watch 3 videos. I know some people find it too much, and it's kind of like demanding time-wise, but anyways. I just decided to share more problems with you guys, and this is the second one for the day. And there's going to be another one in another hour. All right, cool. So let's go ahead and take a look. What can we do when we have variables in the exponents? If you said log both sides, you got it right. But what kind of log are we going to use? Which base? Doesn't matter. You can use base 8, you can use base 7. If you want, you can use base 10, and you can even use natural log, which is what I'm going to use. Natural log is ln, and it's base e. So when I write something like ln a, that just means log a with base e. E being the Euler's number, and I think it's about 2.7. E is a very interesting number. E to the power x, if you differentiate it, you get the same function. If you take the limit as n approaches infinity of 1 plus 1 over n to the power n, you get Euler's number, so on and so forth. A lot of interesting properties. And Euler is one of the greatest mathematicians. I consider him the greatest, but anyways, opinions differ. So, what do I do? A little bit of introduction here about Euler's number and natural log. We're going to ln both sides. That's my first method, ln, which stands for natural log, because French, I think, has it backwards. Correct me if I'm wrong. Some people say it's not that way, but anyways. So we have ln x 8 to the power x minus 1 equals ln 7 to the power x. So what does the lning both sides do? It brings the exponents down. So it's great. It's definitely great because you kind of go from an exponential equation to a polynomial equation, which is obviously a lot easier to solve, especially when it's linear, right? So this gives you x minus 1 times ln 8. I'm not going to use parentheses around the 8 because I think you understand what I'm talking about. And I'm not even using multiplication symbols. Some people find this very, non-rigorous, but it's okay. You understand hopefully what I'm talking about. But it's multiplied. Okay, so what should we do next? Divide both sides by something, put the x's together? No. First of all, think about this. This is a linear equation because you have something like a times x minus 1 equals b times x. And by the way, ln 8 and ln 7 are constants, so we could call them a and b. And this is a linear equation. What would you do first? Distribute, right? Exactly. So that you can put the x terms together. All right, let's do it. And by the way, if you're solving this equation, you would go with ax minus a equals bx, then ax minus bx equals a, and then x times a minus b equals a, and then x would be a over a minus b. Of course, if a is equal to b, then there are no solutions, right? Okay, great. So that's a linear equation with a parameter. And yesterday, remember, we did an equation with parameters. Ax, I think it was like this, right? Ax equals e to the power x or something like this. Anyways, you get the idea. I think it was a e to the x equals x. Anyways, I just like those problems. So I talked to my soul. I should get on with the solution. X ln 8 minus ln 8 equals x ln 7. Now, we're going to put the x ln 8 and x ln 7 together and throw the ln 8 on the other side. Catapult it. Okay, great. Now we can take out x. Nice. Okay. And now what? Divide both sides by ln 8 minus ln 7. And notice that ln 8 minus ln 7 is not 0 because 7 and 8 are different. Duh. So we get a valid solution from here. Maybe I should use my super duper notability powers to make a straight line like this. And here you go. Okay. So that should be the solution, and that actually works, right? It does. That's the only solution. Now, if you don't believe that this works, you can go ahead and plug it in, and we can actually do that if we have time left at the end. But I want to do my second method next. I try not to start with the second method because last time in a video you probably noticed that I started off with the second method, but that the first method I also called it second method. Anyways, shame on me. So it's 8x to the power 8 to the power x minus 1 equals 7 to the power x. And then what I'm going to do is turn this. So I'm going to go purely exponential, and I'm not going to ln both sides until the very end. And even at that point, I don't have to, but we kind of do. Anyways, so what should we do instead? Split up the exponential like this, and then cross multiply, obviously, right? Or you can switch these because they're being multiplied. Some people do that. I do it all the time, but I just want to explain the process here. That's why I'm taking my time. Okay. Then we get the following by division, and we can go ahead and use a common exponent, right? And this really simplifies things. So we have a base, kind of like a to the power x equals b type of equation, basic exponential, and you can use natural log or any other log. Or you can use the definition. How do you find the unknown if it's in the exponent? Use logs. What base should we use? Let's use base 8 over 7. Okay, let's do it. So the definition says log with base 8 over 7 of 8 equals x. So that's the answer. But we could also do the following. If you want, you can use change of base, so on and so forth, or just ln both sides, right? If you ln both sides, what happens? Same thing as before. Let's go ahead and move the x to the front, but this time you're only dealing with one x on one side, so it's a little easier. And from here, x becomes ln 8 over ln 8 over 7. I put the 8 over 7 in parentheses. I don't know because it's a fraction maybe. Okay. What was our first answer? Wow, that looks very much different, doesn't it? Well, not very much different actually, because you can split the log of a quotient. What does the rule say? If you have ln a over b, it can be written as ln a minus ln b. All right, so let's do it. We're going to get from here x equals ln 8 over ln 8 minus ln 7. And as you can see, it basically coincides with the first method. Exact same solution. All right, cool. So now let's go ahead and try the, what was it? I was going to show you something. I think it was to continue with the first method, and I was going to do something. I can't remember exactly. Oh, I was going to check the answer. Yes. Okay, great. So I was just going to check my work, 8 to the power x minus. I just went blank for 5 seconds. So now that happens all the time. ln 8 over ln 8 minus ln 7 minus 1 equals. And by the way, this is a question mark because we don't know if they're equal. And this is kind of painful, but if you make a common denominator, you're going to get ln 8 minus ln 8 plus ln 7 over ln 8 minus ln 7 equals, is this true? These two are going to cancel out, and I'm going to get 8 to the power ln 7 over ln 8 minus ln 7 equals, are they equal? That is the question, to be or not to be, right? Okay, we could kind of raise both sides to that power, so in other words, cancel it out. Now the question is 8 to the power ln 7 the same as 7 to the power ln 8? And the answer is yes. 8 to the power ln b is equal to b to the power ln a. If you don't believe that, ln both sides and you will see. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow or next time with another video. Until then, be safe, take care, and bye-bye.